Welcome to the first devlog of Project-Orin, my turn-based combat RPG with fantasy elements and random generation. This is just a quick rundown of some of the base functionality I have working. It's very much in an early prototype stage, and I just wanted to show a little bit of how it's coming and a way to document what's going on. This first part is going to be me demonstrating how the base game works. There's not a lot here, but enough to get a baseline, and the second part is going to kind of go over some of the technical aspects that I've been trying to overcome, or just issues that I can't fix at all, with only some hope in my chest that maybe I can come up with a solution. But for now, let's just check out how the game works. So we can see here that we have the player information and the enemies. Now this is dynamically generated. None of this is hard-coded except the player level. Everything is dependent on the player level. So if I were to increase the player level, we would see an increase in general health and damage on enemies. Our health is not affected currently. It's just set to 100 for testing purposes, but soon it will be dynamically updated with your level as well, and potentially any skills or abilities you pick up or magic or something. I'm not entirely sure exactly how it's going to work yet. I just know that it will be affected. Everything comes down to the player's level is what I'm trying to get at. There is some room for outliers, of course, and you'll see that in a bit. We have an enemy here. Which is alive. It's a bat. It has 22 health, so it's way under us. We should be able to destroy this thing. It has claws, naturally. So let's start combat. We have him selected. That's the red box. Attack. Looks like I attacked the bat for 8 damage. That's what we see here. And it attacked me back for 8 damage, which it does reflect. So let's keep going. Okay. And looks like I took out the bat and it did not respond. So enemies do respond correctly. If they die, they won't attack you automatically. We can see here our end game. We have 84 out of 100. I could heal. There we go. Now this can easily be spammed. just because it's hard-coded for testing, but eventually there's going to be an inventory system where you can, open your backpack or your inventory and see how many vials of health potions or, whatever you have, whatever kind of magic you have to heal yourself and any companions you may have at the time. This is obviously not the final layout. This is all just development, demonstration, checker patterned textures, so to speak, of the game. Now I can generate a new list. Here we go. We have 3 enemies now. I don't think I'm going to beat them, but let's see what happens. They all only have 22 health. Nothing here is an outlier. And that's actually part of the weakling system. If an enemy is dictated as a weakling, then it will have, I think, 40% of the normal health. And right now it's hard-coded where up to level 15, there's like a 90% chance that an enemy will be a weakling. So them being stronger is actually an outlier. While after level 15, I don't know if that's going to be final, but after 15, they have full health, and it's actually a 10% chance for them to be a weakling. So the outliers are actually the weaklings after 15, rather than the other way around. So there's going to be quite a shift at 15, but it'll probably be more gradual as I program it. I just did that to test the weakling feature. So why don't we give this a go? I'm going to clear the history, or the console. Let's attack. Well, the zombie can do the most damage and also has the less health. So let's attack the zombie first. I'm in combat. Attack. There we go. Oh, we have 3 enemies and 3 attacks. I attacked 1, and they all got a hit on me. In the future, I'm going to expand the combat where there's a chance that an enemy could just choose not to attack. There could be a chance that an enemy could attack twice, but obviously low chance. I'm not going to cause you to be destroyed, but in the future, there's going to be more functionality expanded. So I'm going to keep going. So far, I have made a big dent. Almost half their health is gone. So I'm going to attack them again. There we go. All right, I'm already below 50, and I've only almost killed 1, so I'm going to attack him one more time. That took out the zombie, and now we should just see the bat and the other bat attack. And it looks like I blocked the attack. Look at that. We saw some block events here, which is great. That means that you have a chance to completely ignore an attack, and that's what happened. No damage was given. So the zombie's dead now. So I'm going to heal. There we go. Healed for 25 points. It's going to say 25 even if I'm 99 out of 100 because it's just hard-coded to say that. But there we go. Now, I know that's kind of cheaty. Just for debug purposes in the future, like I said, it'll be inventory-based. So attack. Attack the bat. Bat attacked me. I actually blocked the second bat. Attack. Another attack. Orin blocked the second bat again. Man, I'm just beating him away. Bat's been killed. The other bat gets a hit. Let's go. Let's try to take him out. Bat. There we go. One more time. And I took him out. Now we are out of combat. exiting with 55. Obviously, I kind of, in a way, cheated this combat because I should have died, but we can always generate a new list and get new enemies and heal, and all good for a testing environment to see how this works. Okay, I wanted to talk a little bit about the technical aspect of this game now. I'm not going to be showcasing all the code and going over everything. That would take hours. I would rather just kind of cover the basis of why I chose some of the things I chose and some of the things that particularly stood out to me when developing the game up to this point. For anybody who's interested, this is using HTML, CSS, JavaScript, TypeScript, and React. There is no React libraries or any add-ons that I've gotten in here yet. If that changes, I will update. I do have the draggable library in here. I just haven't implemented it yet. But if I were to say go there, I can see this draggable right here. I'm planning on using that for certain menus so that you can, move them out of the way and compare and contrast, so to speak. I wanted to explain that in traditional game development, say Unreal Engine, Unity, those engines use C++ and C# respectively. Unreal with Unreal Script, I guess. But they traditionally use a class system. You define an enemy in a class, you make a derivative, and then it has all the functionality of that, and you can add stuff like random generation, you can add custom properties that you set, but all the code is in one nice, neat place. And if you need a class to expand that code, then you can do so without having to repeat yourself. This kind of game with the random generation of being able to see these random numbers within a controlled, it's referenced from the player level, but within a relative controlled manner. In order to make that work, I needed to use classes. I used the entity class, which defines how an enemy, or any entity really, exists. They all contain a name, an inventory, whether they're dead, the health, the block chance, the crit dam, and the crit chance. All things that I believe all things are going to naturally have. Whether they use it is irrelevant, but having that stat and referencing it is everything. The reason why I bring this up is because in React, state is normally at the top level and data is passed down to children through props. And those children are re-rendered based on those props changing, or if they have their own state that changes. The problem that came from this is in my combat component, I'm directly influencing the player and whatever enemies are currently passed in. If I go into app, we can see that state for enemies is a list of it's an enemy array. The only thing that React likes is stuff that it can directly mutate. So it's the immutable versus mutable data issue where it likes the fact that there are 1 to 4 enemies in an array. However, it does not care at all about what's inside the enemy classes. It doesn't care about the data in it. It just cares about the actual enemy itself being in the array, where it is in the array. That's why when I generate a new list, it generates everything all fine, but if I were to, say, change the health of a zombie by attacking it, it does update, but that's because I'm unfortunately having to use forced re-renders. We can see an example of that by going into combat. Right here, I'm using a ref. Here's actually a prop that's coming into combat called player re-render, and we can see it down here too, right here, player card current force re-render. All that does is it forces the player card to re-render. There's nothing else in the player card I care about. It's just technically a dumb component, just shows data, but the problem is it's pulling that data from a class, and the class, like I said, state doesn't care. It cares about what's in the array, not what's inside of the items in the array. Unless it was an object, then it would care, but classes are different. That's just how it is. I wanted to use classes because it's something I traditionally understand from C++, but I understand that JavaScript is not the same, React is not the same, but it's the choice that I set out, and so far it's been relatively innocent. The biggest problem I have is that when I re-render a enemy card, that's what these are called, enemy cards. So if I go into the enemy card collection, we can see there's one enemy card. If I got 2, there's 2, and they have all their data of the enemy inside of it. If I were to attack one, all of these are re-rendering because I'm re-rendering the collection. I don't find this to be particularly bad because the amount of data is simple text and it's not going to be a lot. I don't think re-rendering the whole collection is necessarily a huge issue. Now, if it does become a performance issue, I'll find a way to reference the particular card that you're affecting. Right now, the entire card collection is being re-rendered, and the entire player card is being re-rendered whenever anything interacts with it. Inside of the combat component, we can see right here, player re-render from props. whether the enemy has attacked, it's going to await the enemy's attack, and then it's going to re-render whatever it does to the player. I'm thinking of just keeping this because this is the only thing that can re-render the player in this one spot. I can see it being an issue if other stuff re-renders it, but so far this is the solution that I decided to work with. This may change. I'd like it if it could change, but I think this is just how it's going to have to be. At least for the player card and the enemy cards, they're going to have to be re-rendered forcefully just because of the class immutable mutable data issue. Anyway, I just wanted to bring that up to kind of show a little bit of what was going on in that particular section of the game. Otherwise, everything else is behaving appropriately in React. So I wanted to demonstrate really quick how changing the player's level will actually influence the game. So right now, the only constructor argument I have is the level for the player, which is defined here. But if I make it, say, 30, there we go. We can see a dramatic change in the amount of health. The player health, like I said, doesn't update, but we can see the damage of the weapons are also being updated. So the player's level has a massive influence on what happens. I wanted to go over a little bit about how weapon generation works. In entities, we have a weapons folder, and we have three things. I'm going to actually close these. We have three things. We have primary non-lootable lists, which is a list that is generated for particular enemies. So in this case, the bat and the melange have very particular weapons that need to be assigned to them because they can't hold normal weapons. All that it is checking if they have a non-lootable primary weapon. It just references the enemy name, and when it finds that enemy name, it assigns this weapon information to it instead. If we go into the primary weapon list, which is the global list, we can see the sword, the mace, the long sword, and it's just picking a random weapon and assigning it to whatever enemy is asking for it on spawn. And in primary weapon, we can see that the weapon is a class itself, and right here is where it's actually generating the details for the weapon. So we're returning that object that shows the weapon's name, the icon in the future, the description, and some multipliers based on the weapon. And then down here, it's determining the weapon type. So it's saying, you know, are you a weapon that is assigned to your enemy type, or are you a enemy that can hold a weapon? And then if so, get me that primary weapon. The enemy lists work very similar. So if I go into the base enemy list, we can see a bat. It actually has a description. It's not shown yet. Soon there'll be a card that you can click on and open it up and then read about them and see this information and kind of use it. Right now, all the multipliers are set to 1, so they don't have an effect. But in the future, they will actually change. Certain enemies will have certain types of stats, so you can expect a bat to have lower health than like a zombie. There could be that rare bat that's just really powerful. That's all going to be defined later. The logic is the same. It just exports a particular enemy based off this list. It's random. Soon there will be an array of areas or regions they can spawn in, and it'll find enemies appropriate to where it's trying to spawn. That'll be controlled by the map and the tile in particular of the map that's trying to call this method. Right now, it's not used, but in the future, it will be dynamically generated from the map itself, or the dungeon, so to speak. In here, we can see the enemy, which extends entity, like I said earlier. So it has all the functionality and then some more stuff. In this case, this one is calculating its health based on the player level. It's importing the player from here, since that's the only way I can think of to do it. It's importing the raw player, and the player generation happens right in the beginning of the game, so there's no way to accidentally not have a player 1. I mean, it's one of the first lines in the code. So yeah, everything depends on the player. If the player doesn't exist, the entire game won't work. To showcase that, if I go into app and make the player's level 0, everything is going to have the base number, which is 1, no matter what. It's rounding up, so it's probably less than 1, but more than 0. But it rounds up to 1. So we have nothing but 1s. But, you know, as soon as you fix that, say I make it level 1, it's probably going to be roughly the same. Oh, it's got 3, 4. So these are like level 1 enemies that you would expect to see. 1 damage with the occasional outlier of 2, I assume. Nope, all 1. They all have 1 damage. That's got to be tweaked. All right, I just wanted to kind of break that down. I hope that kind of gives an idea of what this game is about, and how I'm kind of proceeding with it. I'm going to update as soon as I can when I get a new feature implemented. The game is not planned as open source. I'm not planning to have a GitHub repository that's public. It's probably going to be private. Once I have a working demo, it'll be free to play online for the demo. But once I release on Steam, the full game will be, I don't know what I'm going to sell it for. I don't know the extent of how complex the game's going to be. I'm going to keep working on it. I'm assuming it's going to take at least a year, maybe more, maybe less. I don't know. But yeah, we'll see how it goes.